If there is another world war, this civilization may go under.
Welcome to GalaxyTones Explorations. You can never fully address the creation of the atomic bomb without mentioning the name of J. Robert Oppenheimer, the country Japan, and World War II. Today, we will embark on an extraordinary journey through the life and legacy of one of the most influential figures of the 20th century and in modern history, Julius Robert Oppenheimer. He was an American theoretical physicist who played a pivotal role as director of the Los Alamos Project and was responsible for researching and designing of the first ever atomic bomb. Due to this, he is best known as the father of the atomic bomb, which ended the Second World War, and this was done by dropping 2 atomic bombs in Japan, leading to the combined death of over 140,000 Japanese, mostly civilians. The creation of such a powerful weapon has raised several ethical questions. Is he a hero who ended a 6-year-long world war, or a killer who led to the death of hundreds of thousands of Japanese? Oppenheimer's contributions to the creation of this powerful weapon during World War II hugely reshaped the course of humanity forever. Oppenheimer's story has lessons for everyone in line with the balance between science and ethics, what's good, what's bad, and what's between. His invention was held by many and condemned by many. And as we delve into his life today, kindly take a drink, relax, and follow through. Try to see if there is something you can take from this and act on in your personal life. J. Robert Oppenheimer was born to affluent Jewish parents on April 22, 1904 in New York City, USA. His father, Julius S. Oppenheimer, was a successful textile importer, and his mom, Ella Friedman, was a painter. Oppenheimer had a younger brother called Frank Oppenheimer. Being a prodigy, Oppenheimer was a versatile scholar and showed early promise in academics. He completed 3rd and 4th grades in 1 year and skipped half of 8th grade. He continued to high school, where he graduated as valedictorian of his class in 1921 at just 17 years old. Before entering university, he fell ill with colitis, which was contracted during a family vacation in Czechoslovakia, and this made it impossible for him to enter university that year. Oppenheimer eventually recovered in New Mexico, a place he eventually grew to love. Oppenheimer majored in chemistry at Harvard University the next year, and in order to make up for his delay in entering university, he took 6 courses every term instead of the usual 4. In just 3 years, Oppenheimer would graduate with a Bachelor of Arts degree in chemistry and move on to pursue experimental physics at University of Cambridge's Cavendish Laboratory, after requesting a letter of recommendation from Ernest Rutherford, who had won a Nobel Prize in chemistry almost 2 decades earlier in 1908 for his investigation into the disintegration of elements and the chemistry of radioactive substances. Things were not moving well for Oppenheimer at Cambridge, and this can be detected from a letter he wrote to his friend. Quote, "I'm having a pretty bad time. The lab work is terrible bore, and I'm so bad at it that it is impossible to feel that I'm learning anything." He eventually tried poisoning his tutor Patrick Blackett with an apple and later confessed this to his friend. Fortunately, Patrick, who would become a future Nobel Prize winner, didn't eat this apple. This action by Oppenheimer was enough to expel him from the university, but his rich parents came through to save the day. The university authorities did not press any criminal charges or expel him, but Oppenheimer was placed on probation and had to have regular sessions with a psychiatrist in London to continue being in the school. Oppenheimer was an avid smoker and was depressed most of his life. He once told his brother, quote, "I need physics more than friends." Oppenheimer studied under Max Born in 1926 at the University of Göttingen, Germany. Born was a German-British physicist known to have coined the term quantum mechanics just 2 years prior in 1924. At the time, Göttingen University was one of the world's leading centers for theoretical physics. Oppenheimer was introduced to quantum mechanics and the groundbreaking works of Albert Einstein and Niels Bohr. These were scientists who were at the peak of their careers. Oppenheimer made friends who went on to great success, including Werner Heisenberg, Pascal Jordan, Wolfgang Pauli, Paul Dirac, Enrico Fermi, and Edward Teller. On 14 September 1926, Oppenheimer wrote to his brother Frank about how much he, Oppenheimer, had come to love Göttingen. Under the supervision of Max Born, Oppenheimer obtained his Doctor of Philosophy degree in March 1927 at age 23. It is reported that after the oral exam, the administrating professor James Frank said, "I'm glad that's over. He was on the point of questioning me." Oppenheimer's ability to grasp information was very high. He spoke 8 languages, which included, in part, French, and India's classical language, Sanskrit, which is known to be one of the oldest languages known to humanity. In this video, Oppenheimer expresses himself fluently in French.
Vous rejoignez un peu la pensée de Socrate. Vous pensez que pour le savant, ce qui est important, c'est de se connaître soi-même.
Oh, pour tout le monde. Pas pour le savant, pour tout le monde.
Et vous pensez que le savant parvient mieux que les autres à se connaître lui-même par le champ de ses travaux et de ses découvertes?
Non, c'est une chose à part. Je crois que les écrivains, les hommes simples, les fermiers, les pêcheurs se connaissent aussi bien, peut-être mieux que les gens savants.
At one time, he learned Dutch in 6 weeks just to give lectures at University of Leiden when he visited the Netherlands in 1926. That was when he was given the nickname Opie. Shortly before he began his professorship at Berkeley, Oppenheimer was diagnosed with a mild case of tuberculosis and spent some weeks with his brother Frank at a New Mexico ranch, which he had leased and eventually purchased. He is noted for saying that desert and physics are 2 of his great loves. Over a dozen papers were written by Oppenheimer in Europe. Oppenheimer did important research in theoretical astronomy, especially as related to general relativity and nuclear theory, nuclear physics, spectroscopy, and quantum field theory, including its extension into quantum electrodynamics. The formal mathematics of relativistic quantum mechanics also attracted his attention, although he doubted its validity. His work predicted many later findings, which include the neutron and neutron star. Oppenheimer, a bomb architect, was no Einstein, but he did Nobel-level work on black holes, said one historian. Oppenheimer was the first to mathematically predict the existence of black holes. In 1939, he and his graduate student, Hartland Snyder, published a paper predicting that collapsing stars, now called black holes, could form. Black holes are regions of space-time with gravitational forces so strong that nothing, not even light, can escape from. The work was eventually ignored as it seemed impossible. How could anything collapse to an infinitely dense point? Over 2 decades later, in the 1960s, a physicist called John Archibald Wheeler revived the idea of black holes, a term he coined in 1967. It was some years later that the evidence sufficed to prove it, and according to Nobel Prize-winning physicist Luis Alvarez, if Oppenheimer had lived long enough to see his predictions substantiated by experiment, Oppenheimer might have won a Nobel Prize for his work on black holes. He is known for the Born-Oppenheimer approximation in 1927, which helped extend quantum mechanics from atoms to molecules, which is his most cited work. He worked on this in Göttingen, Germany, while doing his doctoral work with Max Born. That same year, Heisenberg presented the Heisenberg uncertainty principle, which states that it is impossible to simultaneously know both the exact position and exact momentum of a particle with absolute certainty. In 1931, he co-wrote a paper on the relativistic theory of the photoelectric effect with his student Harvey Hall. In this paper, They based on empirical evidence to correctly dispute Dirac's assertion that two of the energy levels of the hydrogen atom have the same energy. Later on, one of Oppenheimer's doctoral students, Wallace Lamb, determined that this was a consequence of what became known as the Lamb shift, for which Lamb was awarded the Nobel Prize in Physics in 1955. As early as 1930, Oppenheimer wrote a paper that essentially predicted the existence of the positron. This was after a paper by Paul Dirac proposed that electrons could have both a positive and negative charge. Dirac's paper introduced the Dirac equation, which unified quantum mechanics, special relativity, and the then new concept of electron spin to explain the Zeeman effect. Oppenheimer, drawing on the body of experimental evidence, rejected the idea that the predicted positively charged electrons were protons. He argued that they would have to have the same mass as an electron, whereas experiments showed that protons were much heavier than electrons. 2 years later, Carl David Anderson discovered the positron, for which he received the 1936 Nobel Prize in Physics. Oppenheimer had several Nobel Prize winning ideas and was actually nominated 3 times for the prize but never won. When physicist Abraham Peirce asked Oppenheimer about what he thought his most important contribution to science was, Oppenheimer mentioned his work on the electron and its antiparticle, the positron, not his work on black holes. Nobel Prize winner Noel Gelman, who worked with Oppenheimer, had this to say about him. He didn't have sight flesh, which is translated in English to mean sitting flesh. He inspired other people to do things, and his influence was fantastic. This probably explains why Oppenheimer didn't complete most of his works he started. In 1936, Oppenheimer was introduced to a graduate student, Jean Tatlock, who was studying psychology at Stanford University. They were together for quite some time and broke up. He later married Catherine Panin in 1940. They had 2 children. The first child, Peter Oppenheimer, was born in 1941, and Tony was born in Los Alamos in 1944. Both Jean and Catherine had affiliations with the Communist Party. After the death of Oppenheimer's parents in the 1930s, he and his brother were left with hundreds of thousands of dollars. He supported the Communist Party and had friends and acquaintances who were members of the party, his brother and his brother's wives included. This would pose a major problem in the coming years. Throughout the development of the atomic bomb, Oppenheimer was under investigation by both the FBI and the Manhattan Project's internal security arm for his past left-wing associations. Oppenheimer acquainted himself with the Hindu texts and also learned the Sanskrit. He read literary works like the Bhagavad Gita and the Megiddo and pondered them through. He is noted for citing parts of these literary works. He wrote to his brother that the Gita was very easy and quite marvelous, and called it the most beautiful philosophical song existing in any known tongue. He later gave copies of it as presents to his friends and kept a personal worn-out copy on the bookshelf by his desk. He even nicknamed his cat Garuda, the mountain bird of the Hindu god Vishnu. But he never became a Hindu, neither did he worship at any temple or worship any god. Yes, Oppenheimer had no administrative experience, which is supposed to be one of the key qualities of anyone who would be leading such a huge experiment. He also had no Nobel Prize, unlike many of the people whom he would be administering, and worst of all, he had a doubtful political background, having associations with known communists in the late 1930s, but Lieutenant General Leslie Groves moved on to pick him over. As a nuclear and quantum physicist, Oppenheimer was well respected by the scientific community, and his grasp of physics was outstanding. He had specialized in the newly discovered neutron particle by James Chadwick in 1932. The neutron is a basic building block of an atom, which when fired at a heavy unstable atom's nuclei causes them to split apart. This is known as nuclear fission, and this releases more neutrons leading to a chain reaction which produces huge amount of energy, and this is what powers an atomic bomb. Interestingly, both Ernest Rutherford and Albert Einstein didn't think that it would be possible to generate some significant amount of energy from radioactivity that had been discovered decades prior by Henri Becquerel, Marie and Pierre Curie. There are actually a couple of ways you can implement in order to split the atomic nucleus, which we call fission. In 1932, before the neutron particle was discovered, Ernest Wharton and John Cockcroft won the Nobel Prize for working on one of such experiments. In their experiment, a proton was accelerated through a large electric field targeting the lithium nuclei. Splitting occurred, but the problem here is owing to the fact that both the lithium nuclei and proton have a positive charge. The repulsion experienced in the process reduces the effective probability for collision. This wasn't an efficient means to approach fission, as averagely just about 1 in a billion protons will ever hit and split the nuclei. A more efficient way was needed. The discovery of the neutron figuratively seems to be the starting point of the creation of an atomic bomb. The neutron has no charge, unlike the proton and electron. This means that it isn't affected by the attraction law, as it can't be repelled or attracted. After this premise and foundation was firmly established, LiQWYD, in the very next year, 1933, started thinking about the possibility to approach fission using neutrons. His idea was to slap the nucleus of a heavily unstable atom which wasn't yet known with a high-speed neutron, and this was placed to produce 2 extra neutrons, 1 each. The neutrons at high speed will repeat the same process, leading to a chain reaction. Within a short time interval, there will be an exponentially huge number of neutrons, and this would lead to an explosion. The idea was set, but the element wasn't yet known. It took 6 good years of hard work to solve this problem. In 1939, the same year the Second World War started, Luis Alvarez saw in a newspaper that fission using neutrons was possible. He gave Oppenheimer a heads up about 2 German chemists, Fritz Strassmann and Otto Hahn, who had achieved fission using neutrons, and although initially skeptical, Oppenheimer quickly realized that it was possible. Of the many isotopes of uranium, the arrangement of particles in uranium-235 is most unstable. When a single uranium atom with mass number 235 and proton number 92 is bombarded with a single neutron, the new mass number of uranium becomes 236. This makes it highly unstable, so it's placed to krypton with mass number of 89 and proton number of 36, and barium with mass number of 144 and proton number of 56. It releases 3 extra neutrons, but more importantly, it also loses a bit of mass, which is released as energy, as Einstein's energy mass equation predicts. This energy, although small, when gathered from trillions of atoms due to the resulting chain reaction, produces a huge amount of energy which causes explosion. Around this time in 1939, there were speculations that Germany had uranium and was working on building a possible atomic bomb. LiQWYD, the original initiator of fission using neutrons, wrote a letter signed by Albert Einstein to the then President of the United States of America, warning about Germany's plans. This was when the USA decided to create the atomic bomb before the Germans did. As the world stood on the precipice of World War II, Oppenheimer's brilliance and expertise captured the attention of the scientific community. In 1942, he was appointed the scientific director of the Manhattan Project, a top-secret initiative led by the United States. The project's goal was to develop an atomic weapon before the Nazi Germany would acquire one. Oppenheimer assembled an exceptional team of scientists, including Enrico Fermi, Hans Bethe, Richard Feynman, and others, who became known as the Los Alamos scientists. Their collective genius and collaboration marked a pivotal moment in history as they raced against time to build the first atomic bomb. It is reported that Oppenheimer invited Linus Pauling, a 2-time Nobel Prize winner, to be head of the chemistry division of the Manhattan Project, but Pauling refused, saying he was a pacifist. The challenges faced by the Los Alamos scientists were immense. They had to overcome technological hurdles, theoretical uncertainties, and ethical dilemmas surrounding the use of such a devastating weapon. Nevertheless, their unwavering determination and sense of duty to their country propelled them forward. After years of intense research and testing, the moment of truth arrived on July 16, 1945, at the Trinity test site in New Mexico. Here, the first ever atomic bomb was detonated, producing a massive explosion that illuminated the skies and shook the very foundations of science and morality. The Trinity test was scheduled for 4 a.m., but due to storm, it was delayed to 5:29 minutes 29 seconds. There was some amount of fear, however. One thing the scientists couldn't really figure out was whether the explosion would catch up the entire atmosphere, especially as oxygen supports burning, and particularly nitrogen as well is an unstable gas in air. As the countdown took place, Brigadier Thomas Farrell gives a clear picture of Oppenheimer's actions. He recounts, Dr. Oppenheimer, on whom had rested a very heavy burden, grew tenser as the last seconds ticked off. He scarcely breathed. He held on to a post to steady himself. For the last few seconds, he stared directly ahead, and then when the announcer shouted, "Now!" and there came this tremendous burst of light, followed shortly thereafter by the deep growling roar of the explosion. His face relaxed into an expression of tremendous relief. Just 6 kilograms of plutonium resulted in an explosion which equaled 25,000 tons of TNT. The atmosphere was hot and the desert sand melted to a mineral now known as trinitite. The vibration could be felt 160 kilometers away. The mushroom cloud rose to about 12 kilometers into the sky. Fortunately, the atmosphere didn't light up. But can we pause for a moment and think about this massively fast pace of discoveries that took place within just 13 years of discovery of the neutron particle? In 1932, a neutron particle is discovered by James Chadwick. In 1939, the neutron particle is discovered to split heavily unstable atoms or nuclei. Now, 6 years later, in 1945, a physical object employing the idea of nuclear fission is developed. Witnessing the awe-inspiring power of the atomic bomb, Oppenheimer famously recalled a line from the Hindu scripture, the Bhagavad Gita, quote, "If the radiance of 1,000 suns were to burst at once into the sky, that would be like the splendor of the Mighty One. Now I am become death, the destroyer of worlds." In 1965, he recalled the moment this way.
The world would not be the same. Few people laughed. Few people cried. Most people were silent. I remembered the line from the Hindu scripture, the Bhagavad Gita. Vishnu is trying to persuade the prince that he should do his duty, and to impress him takes on his multi-armed form and says, "Now I am become death, the destroyer of worlds." I suppose we all thought that one way or another.
In some sort of crude sense, which no vulgarity, no humor, no overstatements can quite extinguish, he said, 2 years after the Trinity explosion, "The physicists have known sin, and this is a knowledge which they cannot lose." Listen as Oppenheimer explains what he meant by this statement.
Long ago, I said once that in a crude sense, which no vulgarity and no humor could quite erase, the physicists had known sin. And I didn't mean by that the deaths that were caused as the result of our work. I meant that we had known the sin of pride. We had turned to affect, in what proved to be a major way, the course of man's history. We had the pride of thinking we knew what was good for man. And I do think it has left a mark on many of those who are responsibly engaged. This is not the natural business of a scientist.
The weight of the atomic bomb's destructive potential no doubt weighed heavily on his conscience, as it did for many of his colleagues. Tragically, the atomic bomb's devastating power was unleashed upon Japan exactly 3 weeks later, on August 6, 1945. The United States dropped an atomic bomb on Hiroshima, followed by a second bomb on Nagasaki 3 days later. These were civilians, and the aftermath was catastrophic, resulting in the loss of hundreds of thousands of lives immediately or later due to effects of radiations, and leaving a permanent scar on the collective human memory. Between 100,000 to 200,000 people are estimated to have died. Almost 2 weeks later, on 17th August, Oppenheimer expressed his wish in writing to see nuclear weapons banned. This didn't go well between he and President Truman, who succeeded President Roosevelt. The bombings of Hiroshima and Nagasaki raised profound moral and ethical questions about the use of such weapons. The scientific community was forced to confront the dual nature of their work, the potential for both great advancement and grave consequences. Oppenheimer's involvement in the Manhattan Project brought him both praise and scrutiny. While he was hailed as a hero for his pivotal role in hastening the end of the Second World War, he also faced criticism for his part in creating such a destructive weapon. As the nuclear arms race escalated during the Cold War, the US government began to question Oppenheimer's loyalty due to his past associations with communist sympathizers. In 1951, Edward Teller and mathematician Stanislaw Ulam developed what became known as the Teller-Muller design for a hydrogen bomb, which was then called SUPER. Oppenheimer didn't support the idea of creating the hydrogen bomb, which was way more powerful and deadlier compared to the atomic bomb, especially after witnessing firsthand the gruesome effects of the atomic bomb. He became an enemy to all those who were proponents of the hydrogen bomb. Oppenheimer had been under surveillance throughout the period of creating the atomic bomb owing to his communist associations in the past, and his opponents feared that the fame he has grown to acquire made him dangerous. A hearing was held which would end in his security clearance being stripped off him. During the hearing, Edward Teller, a strong proponent of the hydrogen bomb creation, testified against Oppenheimer, saying in part, "I feel that I would like to see the vital interest of this country in hands which I understand better, and therefore trust more. In this very limited sense, I would like to express a feeling that I will feel personally more secure if public matters rest in other hands." Tragically, in 1954, Oppenheimer's security clearance was revoked and he was stripped of his position in the Atomic Energy Commission. This marked a turning point in his life as he shifted his focus to teaching and scientific pursuits, reflecting on the moral implications of his work. Throughout the remainder of his career, Oppenheimer continued to make significant contributions to science and education. He served as the director of the Institute of Advanced Study at Princeton, where he mentored future generations of physicists and fostered an environment of intellectual explorations. One question that has really been on the minds of many is why he never won a Nobel Prize after all the works we know him to have done. J. Robert Oppenheimer was a man of many talents. He was unique. The varied nature of his brilliance caused him not to focus fully on any one field. In an interview with a Science magazine, physicist and historian emeritus at Hofstra University, Professor David C. Cassidy, the author of the book J. Robert Oppenheimer, mentions, as I've paraphrased, that Oppenheimer was not absolutely devoted to physics the way one of the great physicists like Albert Einstein, Richard Feynman, and others would be. Physics was one of his many passions. At the time he was doing physics, he read a lot of literature and languages. Because his scientific attentions often changed rapidly, he never worked long enough on any topic and carried it to fruition to merit the Nobel Prize. Though his investigations contributing to the theory of black holes might have warranted the prize had he lived long enough to see them brought to fruition by later astrophysicists. From what we've seen so far, It would be fine to say that the popular notion about Oppenheimer inventing the bomb isn't entirely true. It was rather the work and combined efforts of several scientists and theorists, directly or indirectly, Oppenheimer himself included, spanning through some decades that led to the final product, the atomic bomb. A typical example is that of Albert Einstein, who wasn't recruited to work on the Manhattan Project. His left-leaning views made him a threat, but he played a very major role relating to the start of the project. J. Robert Oppenheimer died on 18 February 1967 at just 62 years old. An asteroid 67085 Oppenheimer was named in his honor on January 4, 2000, as was the lunar crater Oppenheimer in 1970. On December 16, 2022, United States Secretary of Energy Jennifer Granholm vacated the 1954 revocation of Oppenheimer's security clearance. Her statement said, in 1954, the Atomic Energy Commission revoked Dr. Oppenheimer's security clearance through a flawed process that violated the Commission's own regulations. As time has passed, more evidence has come to light of the bias and unfairness of the process that Dr. Oppenheimer was subjected to, while the evidence of his loyalty and love of country have only been further affirmed. In retrospect, Oppenheimer's story is a testament to the complex interplay between science, ethics, and history. His contributions to the atomic bomb's creation highlight the importance of responsible and ethical use of scientific knowledge for the betterment of humanity. As we reflect on Oppenheimer's life and the monumental events of the 20th century, let us not forget the lessons we can learn from this pivotal era. Let us remember that knowledge and innovation come with a responsibility to use them wisely and for the greater good. In conclusion, J. Robert Oppenheimer's life and involvement in the Manhattan Project shaped the world we live in today. As we remember the past and strive for a better future, may his stories serve as a powerful reminder of the profound impacts science and innovation can have on our lives and the importance of using knowledge responsibly to create a better world. Thank you for joining me on this profound journey through history.
I have been asked whether, in the years to come, it will be possible to kill 40 million American people in the 20 largest American towns by the use of atomic bombs in a single night. I am afraid that the answer to that question is yes. I have been asked whether there are specific countermeasures against the atomic bomb. I know that the bombs that we make in Los Alamos cannot be exploded by such countermeasures. I do not think there is any foundation for the hope that such countermeasures will be found. I have been asked whether there is hope for the nation's security in keeping secret some of the knowledge which has gone into the making of the bombs. I am afraid there is no such hope. I think the only hope for our future safety must lie in a collaboration based on confidence and good faith with the other peoples of the world. If there is another world war, this civilization may go under. We need to ask ourselves whether we're doing all we can to avert that. We need, I think, to learn to understand the realities of life abroad, not so much in terms of slogans as in terms of the lives of men. In our response to these realities, there is hope for peace.